All right, today we're talking about one of the most dangerous objects on the entire planet, the elephant's foot of Chernobyl. We're going to trace its whole story, from the moment it was born to the absolute mess it is today.
So, what happens when a monster gets old? You'd think it just fades away, right? Loses its teeth. But with this thing, the story is way more complicated. And honestly, in some ways, it's getting even scarier.
See, it's not dying. It's changing. It's morphing into something new. So today, we're going to follow its entire 4-decade life story, from its violent creation to the unpredictable, crumbling thing it is right now.
Okay, let's start at the beginning. Its lethal youth. To really get what this thing is today, you have to see what it was like right after the Chernobyl disaster in '86. And believe me, it was a beast of almost unimaginable power.
So check this out. Just a few months after the meltdown in December '86, this thing was blasting out 10,000 rengens an hour. Now, what does that even mean? Well, a dose of about 500 rengens is lights out for a human. This thing was pumping out 20 times that lethal dose every single hour. It's just insane.
So yeah, at that level, you're looking at a fatal dose in just 3 minutes. 3 to 5 minutes, and it's over. Getting anywhere near it was a guaranteed death sentence. No ifs, ands, or buts.
And it wouldn't be a slow death either. We're talking immediate, acute radiation syndrome. The symptoms would hit you in seconds. It was this invisible, silent killer that got you instantly.
So what made it so unbelievably deadly right at the start? Well, it was this nasty cocktail of radioactive isotopes. The big one at first was iodine-131. Now, this stuff has a half-life of just 8 days. Think of it like a firework. It burns incredibly bright and hot, but it also burns out pretty fast.
As those firework isotopes burned themselves out, the whole nature of the radiation started to shift. You know, the monster was getting older, and its personality was changing.
And this timeline shows it perfectly. Back in '86, the main problem was that super intense iodine-131, but fast forward a decade to '96, and the big bad is now cesium-134. Then you get to today, and we're dealing with the really stubborn stuff, cesium-137 and strontium-90. It's a total changing of the guard, where each new isotope brings its own unique long-term brand of trouble.
Now, the dose rate today has dropped a lot. We're down from 10,000 to about 400 rengens an hour. But, and this is a big but, don't let that fool you. An hour next to this thing is still almost certainly fatal. It's not the instant killer it once was, but, oh yeah, it's still a killer.
And here's where things get really interesting. As that powerful gamma radiation, which is kind of like super intense X-rays, starts to fade, a totally new kind of threat pops up: alpha emitters. We're talking things like plutonium. Now, alpha particles are big and clunky, they can't even get through your skin. So outside your body, not a huge deal. But if you breathe them in, they become tiny wrecking balls inside your lungs. And that little detail is going to be so important for what happens next.
So here's the twist. The monster isn't just getting weaker radiologically. It's literally destroying itself from the inside out. That solid, rock-hard lava is turning into something else. This whole self-destruction thing has a name: metamictization. It's pretty wild. For almost 40 years, those alpha particles we mentioned have been acting like microscopic bullets, just constantly shattering the glassy structure from the inside. And on top of that, you've got humidity from the air getting in, making the whole thing swell up and flake apart.
And the result? It's just staggering. What was once this solid, almost indestructible block of lava is now described as having the consistency of sand. It just crumbles. This isn't just a small change. It's a complete physical transformation. And now those dangerous alpha particles have a way to escape.
And this change from a solid rock to a pile of radioactive dust has created these brand new, unpredictable dangers. It's like the old monster is learning new, scary tricks.
Okay, first up is this weird thing called recriticality. So when they built the huge new shelter over the reactor, things started to dry out. You'd think that's good, right? Well, here's the paradox. Water actually helps slow down nuclear reactions. So as the water left, the neutron activity started to go up. It was like the embers of the fire were starting to smolder again, getting closer to reigniting.
The second new danger also involves water. Water is reacting with the corium, that's the lava stuff, and it's creating these brand new, bright yellow minerals on the surface. Now, here's the problem. Unlike the original lava, these new crystals dissolve in water really easily. So if there's ever a major flood, it could just wash all this radioactive material right down into the groundwater. A total nightmare scenario.
So, where does that leave us? Let's talk about the unending legacy of this thing. After all this, how has the threat really changed? This table really nails the difference. Back in '86, the hazard was all external. Get too close, you get zapped with gamma rays, and it's a very certain, very quick end. But now, the threat is internal. It's about breathing in a tiny speck of that radioactive dust, which gives you a long-term, maybe you will, maybe you won't risk. The danger has literally gone from a solid, immobile killer outside your body to a mobile, statistical threat inside it.
And look, these are challenges we can kind of wrap our heads around, right? The gamma radiation will keep fading on a schedule we can predict. And containing dust, I mean, it's a massive engineering problem for sure, but it's a problem we can at least try to solve.
But then there's this number, 24,100 years. That's the half-life of the plutonium-239 that's in that dust. And that leaves us with the question that's just staggering. The monster's immediate, furious danger is fading, yeah, but it's being replaced by this quiet, persistent poison that will last for a timescale our brains can't even really process. The monster isn't dying. It's just settling in for the long, long haul. So how does any civilization guard against a threat that is guaranteed to outlive us by thousands and thousands of years?